CBT Nuggets JNCIS Security Series, Intrusion Detection and Prevention, IDP or IPS Fundamentals. Now, the reason I have IDP or IPS is because IDP is really kind of the older way to describe this in Junos, but it's the way it's described on the exam. We really refer to it now kind of the industry standard IPS, Intrusion Prevention Services, or Intrusion Prevention Systems. Now, let me let you in a little industry secret. This is one of the areas in security, whether it's Juniper or Cisco or SonicWall or Checkpoint or whatever, this is really one of those areas to set yourself apart from the herd, okay? It's easy to find people that understand how to put together a basic firewall or a stateful firewall or even set up a VPN. But this is the area that really sets people apart. And part of the reason is because it's responsible for what we call zero-day or day zero countermeasures. In other words, rapid deployment and coding of aggressive techniques for stopping attacks in their track the day they occur. So you can really set yourself apart and carve out a place for you in the security industry if you can start to build on these skills, these fundamentals I'm going to show you here, and move forward with them. Okay, so that's a little piece of advice for you. It's my favorite security component by far. I enjoy it. I enjoy it on Juniper. I enjoy it on Cisco. It doesn't matter. I think you're really going to like this feature. Let's check it out. Now, right off the bat, let me tell you that Juniper calls this intrusion detection and prevention historically, IDP, even though we're seeing them make a move towards calling it IDP IPS, because really IPS is the industry standard. I think they've tried to hold off as long as they could because this is what Cisco calls it, but they had to finally capitulate, and you might see it called IDP in existing documentation, but really it's all IPS going forward. So we want to think about it as IPS and then different types of ways to deploy IPS moving forward. So on the exam, they'll refer to this as IDP, but really let's just think of this moving forward as intrusion prevention services. Now, this is a critical aspect of your network security, so it should be part of your firewall system, okay? Either integrated into existing devices or appliances like the SRX, and IPS is integrated into your SRX all the way from the 100 series all the way up to the high-end devices. Or it could be some standalone solution where the sensor, which is what we call these devices, the sensor is a standalone appliance or box, or it's some software running on an operating system like Unix or Linux, for example. This needs to be an end-to-end solution. So we think about deploying this IPS solution at different places, different choke points in our network, starting with the high value targets first. So probably if you're looking at your organization, you want to protect the DMZ zone and those public facing services out there. If you have e-commerce servers that are doing that, if you're based on internet commerce, internet business, then you're going to focus on that. Then you're going to look at protecting the server farm, the data center, and then you want to look at internal targets, key workstations in key departments like the finance department, accounting department, research and development, things like that. So what we're trying to deal with here are advanced, mutating, and stealth threats with the ability to generate our own zero-day protection, because we want to think about this as an add-on. We know that we've got packet filtering, we've got static packet filtering done with firewall rules. We know we also have stateful packet filtering. We have the ability to do advanced inspection or deep protocol inspection. We looked at some of our screen countermeasures in the previous nugget, so we're basically adding this on to that service to provide better protection. One of the real key issues here is that networks are becoming more borderless. And what that means is we're seeing a big influx of this phenomenon known as BYOD, especially if you're in the medical industry, the healthcare industry, financial industry. People are bringing their own devices into the network that are wireless phones that are they're merging their own personal use with business use. This is a big thing in healthcare, okay? So when that happens and people can leave the network, leave your corporate environment with their phone or their pad or whatever, that makes your network borderless because they're taking data out and they're also trying to connect back in again from their home or remote offices or branch offices or other facilities. So this is an ongoing challenge. So we need this feature to help us look at known and unknown threat agents and attacks from layer 3, the network layer, all the way up through the application layer. So what we're doing is we're going beyond what just packet filters do. We're looking at all the bits. We're scrutinizing all of the bits within the packets, looking for particular attack vectors. Now, as you can imagine, this is pretty processor intensive, right? So we want to basically only function on the traffic that gets through the other components. So what I mean by that is you're not going to put and if you looked at the order of processing, if we go back to that diagram, which you can do and you can review it back in the previous nuggets, if we looked at the order of processing on a Juniper SRX, we'll notice that the IDP functionality happens after a lot of the other policy and firewall rules. We know that screen happens first. So we do the screening, we do the firewall rules, we do the policy, we do network address translation, then we see the IDP or IPS taking over. That's the way it should be, okay? We want to operate on traffic that gets through. So it can either be logically after the firewall functionality or physically after the firewall functionality if it's on a separate device behind the upstream firewall. Okay, so we want to think of it that way. So that's the way it should work. Because, it's not going to be the first line of defense ever. Okay, the first line of defense has to be static and stateful packet filtering and other screening options, right? But we need IPS, and we need it along with antivirus, anti-spam, and other anti-X capabilities, content filtering, for example, application layer gateways. So this is an additional component, right, in our firewall system, but it's mission critical. And so we want to focus on that here in this nugget. Now, before we jump into some key IPS terminology, and this is important terminology, okay, you have to really master this to understand anything further beyond this. Move this up a little bit. As we look at this very popular SRX 220 here, one thing we want to understand about the way that we process the packets using IPS on this SRX gateway is this. When you're doing this with the SRX, you have a ton of selectivity or granularity, okay? If you were deploying, let's say, a Cisco IPS sensor, for example, you basically say it's going to be in inline mode where it's in the line of traffic, or it's in promiscuous mode where you're getting copies of the traffic. Now with inline mode, you don't have a whole lot of granularity or selectivity. It's basically in the line of traffic. With the promiscuous mode, you can control what you're analyzing, but you have to do it on the switch that you're connected to. You have a trunk port to a switch, and you can do span on the switch or RSpan or VLAN mapping, things like that. But here on the SRX, since you can enable IPS processing on a rule-by-rule basis, okay, by applying it to a firewall rule, you get incredible granularity. So if traffic is not marked by a firewall rule to be processed by IPS, then it just basically bypasses the IPS engine, which is pretty cool. Now, beyond just the granularity of saying, okay, I want to apply IPS traffic processing to certain firewall rules, I can also, within that traffic that I'm processing, I can also get even more granular based on the way I configure my rule base. Okay, so we'll look at that here as we get into the configuration. But let's look at some key terminology here, okay? First of all, we have a false positive, and false positives occur in all different types of software. False positives occur if you have an anti-spam, right? If it's not really a spammed email, it's a real email from your cousin, but it calls it spam and it puts it in a particular folder or it flags it, well, that's a false positive. The same thing with antivirus, okay? If a particular software implementation, you download a plugin and your operating system says, hey, this is a virus, but it's really not, that's a false positive. Well, the same thing is happening here. Let's say you're applying IPS inspection to a firewall rule and it says, hey, I'm I'm going to fire alarm because this is an attack, but it's not really an attack. It's benign traffic. That's a false positive. And one of the goals of tuning our IPS environment is to try to reduce false positives as much as possible. Now, false negatives are really the opposite, okay? This means there was an actual attack. It really was a threat agent and it wasn't detected, okay? And we want to get rid of those as well too. Typically, false negatives occur because you've just poorly implemented your IPS, or you need to rely more on upstream security components like, you know, packet filtering, stateful packet filtering, and other screening options, okay? Because there's an inverse relationship between these two. If you try to reduce false positives, you probably create more false negatives. If you try to explicitly generate fewer false negatives, well, that can lead to more false positives, okay? Now, a true positive is basically you detected the attack as expected. So that's a good thing. We want more true positives. Also, a true negative is it was benign traffic, okay? It was something that I expected, it's an application that I want on my network, and an alarm was not fired, okay? So these are the 4 categories. You got to know those. Now, something else we need to understand is there's 3 different modes for deploying IPS on our device. Now, we're really only interested in one mode. On the lower end SRX, the 100, the 210, the 220, we're going to be using integrated mode, where the traffic is processed by the NPU, or the network processing unit. So on the branch devices like the ones we're using, this is the mode we use. It's integrated into the Junos, okay? The firewall process handles the IPS process, in other words. Now, the processors on our Juniper SRXs, they are multi-core, they're multi-threaded, so we can do this concurrently without any problem. This is the default option, even if you're using a high-end SRX, is integrated mode. Now, if you are using a high-end SRX, okay, then you can also do what's called dedicated mode, where you dedicate the entire IPS processing as a separate process. You can also determine how much of it'll be an SPU in that circumstance, okay? So the high-end devices use the SPU. You can determine how much of it's dedicated to the firewall and how much is dedicated to the IPS, okay? So dedicated mode. The inline tap mode, this is the equivalent, what we call IDS or promiscuous mode in Cisco, where it's basically you're operating on copies of traffic. This is also a high-end operation, not the default, but you're operating on copies. This is a kind of a separate choice because it's not inline, so you don't really get intrusion prevention. You don't get the aggressive ability to stop traffic before it gets into your network. But it's good to analyze traffic, for example, in your DMZ or maybe in your server farm or your intranet, for example, to determine if you want to deploy more aggressive integrated mode activities or dedicated mode activities. Then we have attack objects. Okay, there's 2 different types of attack objects. There is the protocol anomaly attack object, and this is really the anomaly detection feature of the SRX IPS. These are predefined, okay, and they're really based on the protocol. So what they're doing is they're looking at protocol conformance, making sure that based on the RFC of the application or service that they're adhering to the specifications, okay? If there's not an RFC for it, then it'll be built into an SRX detector engine, looking for specific patterns. We cannot create protocol anomaly objects, okay? This is built-in code, but you can create your own custom attack objects that can utilize these detector engines. And the newer your iOS, okay, the more protocol anomaly attack objects you're going to have. So the newer the code, the more robust it's going to be. Now, what we typically base our IPS on is the signature-based attack object. And this is a lot like the signatures you have in an anti-spam engine or an antivirus engine. You have predetermined things you're looking for based on regular expressions, right? You're looking for patterns in email like Viagra and different spellings of Viagra. You're looking for certain patterns in viruses or worms. Okay, well, the same thing here. You've got a signature base of over 6,000 predefined attack objects that use things like regular expressions to identify and characterize thousands of different attack vectors, thousands of different bits that show up in the packets that represent known attacks against your network. Now, you also have the ability to create your own custom attack objects, and that's really where you earn your salt, right? Is when you get to the ability to kind of create your own customized attack objects for 0-day or day zero attacks. Now, that's going to be something you're going to look at as you go beyond this JNCIS security. That's kind of an advanced feature, but it's something to look at to add value to yourself, to your company right now, or when you're out there in the job market. Also, you have severity levels, and these are going to define the impact that these attacks have. So these attack objects have default severity levels assigned to them, okay, starting from very low severity informational up to critical severity. So an attack object might be informational, right? It's not malicious, but it just gives you information. Maybe it's some kind of reconnaissance that can be gathered, basically showing information about things that are running on the system, for example. Warnings, these are suspicious, could be attacks, could be threat vectors like scans or reconnaissance. You have minor severity. These are attacks that are trying to do, let's say, leakage, trying to exploit vulnerabilities on particular targets. Then you have major severity. These are trying to get user access and do escalation of user access, for example, denial of service, distributed denial of service, trying to crash systems. And of course, the highest is the critical. These are trying to get root level access to systems, crash the systems, do complex evasive techniques, definitely nefarious and evil malicious code. Okay, so those are the 5. This is I spent 10 minutes on this at least. You've really got to make sure that you review this for the exam, because this is a huge area of testing. It's also something you have to really nail down before you move forward with IPS implementation. Okay, before we look at the configuration of IDP or IPS on the SRX, let me give you the bad news. And I didn't give you the bad news at the outset or any time along the way, because I didn't want to taint the information that was so important to you from a real world and exam standpoint. But the bottom line is, this is a feature license that you have to pay for. So for, let's say, on my SRX 210, a 3-year IDP license is somewhere between $400 and $650, which I'm going to tell you right now, I don't have that license on my SRX. In my lab environment, I use dedicated standalone sensors for my IPS solution. And by the way, neither should you go out and purchase and spend that money to put that on your SRX just to pass this exam. Okay, let me just tell you that right off the bat. You don't need it. I'm going to show you all the information that you need here. Now, that's not unlike what other vendors do as well. For example, the Cisco solution on their integrated services routers, you have to get the iOS IPS feature license for their IPS, and it's a license to keep paying for over and over and over. The downside of these licenses is they're not a one-time fee. They're like 1-year licenses, 3-year licenses. You have to renew them over and over. Now, once your license is valid, then you can go in up and get updates. You can get automatic updates for your security package so that you make sure that your IDP engine has up-to-date information in it for some of the new attacks out there. So that's, I guess, kind of the good news. But the bad news is, it's pretty costly to have this on your SRX. As a matter of fact, as we go forward in this Nugget series, we're going to look at several more features of the SRX that also demand going up and spending hundreds or thousands of dollars to add that functionality to your SRX. We're not going to worry about that, especially since the main goal of this Nugget is to pass the exam. Either way, you'll still have the information you need to go deploy this on your own if you're able to go make that investment. So let me show you first off some of the key commands that you need to be aware of that you would go through if you had this license on your device. Okay, so in operational mode, you will do a show security, and the main command set will be edit security or show security IDP. So if you do security package version, and you need to know these commands for your exam, show security IDP security package version will allow you to see what attack database version you have. It'll be dated, it'll have a version number like 12 dot something. Okay, if you want to download attack objects, which includes sensor updates, you can do this, but you have to have it obviously on your outside interface. You need to be connected to the internet. Okay, so you would do request security IDP and then security package, and then you would follow that command up with the keyword download, and then you want to say full update, full dash update. So request security IDP security dash package download full dash update will download this from, it'll be netscreen.com or some other website that's related to Juniper. Okay, so it'll download that. You can also check on the status. Once you get that package, you'll do a request security IDP security package install. Okay, so the first thing you do is download it. Then the next thing you do is you install it. And you can also follow up the download or the install with the status keyword along the way to see what the status is. And then the main command, once you've downloaded and installed your attack objects and sensor updates, would be to show security IDP status. Now you can also configure automatic updates, and you would do that as well. That would be in configuration mode. And you would say edit security, and it would be IDP and then security package. So this is the context you have to be in to be able to download this. And then you could set the start time. You could put a date on there, like every 24 hours. You could have a timeout set up. So that's a very important thing. It's just to know that you need to get into this particular mode to set your install automatic. That's the command set install and then automatic. Okay, so let's assume that you've gone through those steps. You have gone and you've gone to Juniper, you've gone to some third party, you've gone to your vendor, for example, that you purchased the SRX from. Obviously, if you're going to buy one of these brand new, consider all of the different packages you're going to need, all the different extra additional feature licenses. And when we finish with this Nugget series, you'll have a pretty good idea of the feature licenses you're going to want to add. This would be definitely one of them. And so from that vendor, either after the fact, once you've downloaded your security package, or at least you've updated it, right? Now you're ready to go ahead and create your IDP services. And of course, all of the actual signatures or the attack objects will be activated. So we're going to do it in both directions on the SRX. So let me show you how this is done. We need to edit security policies, and it's in the from zone. As I mentioned, this is based on our policies. Our from zone will say first is the trust zone, and the to zone is the untrust zone, followed by the policy keyword, and then we need to name this. So we'll just call this the IDP policy. So we're in the context of our IDP policy, which in this case is going to be from the trust zone to the untrust zone. Then we'll set match. The source address will say any, and the destination address will say any, and we'll also say what applications, and we'll do any. Then, so we have the match statement, so we need the set then statement, and we're going to permit, or we're going to apply this application services, and then of course IDP. Let's just do a question mark though and see some of our options there. You can see we're going to add this intrusion detection and prevention service. So IDP. Now that's just from the trust zone to the untrust zone. So we need to go ahead and do this again. It's going to be a different policy. Okay, so let's exit out of here and do edit security policies from zone untrust to zone trust. And we'll call this policy IDP policy 2. Policy 2, that'd be a different name. So the trust to untrust was called IDP policy, and the untrust to trust is called policy 2. So we're in that configuration mode, as you can see. So we'll set match source address any, destination address any, and application any. And then finally set then permit application services, and of course IDP. Now that's the basic configuration that you would have for your SRX. Once you've gone through the hoops of paying for your license, downloading it, updating the license, setting up an automatic update, then you would go and you would apply it individually to different zones. So these are unidirectional. So the security policy is going to apply this IDP for traffic flowing in one direction. I want it in both directions, from the trust zone to the untrust zone and vice versa, so I have two policies. And of course, I could do a show security policies, and I could view that along with everything else. Now that's the basic configuration which you really need to know for the exam. As you move forward in your Juniper security experience, you'll learn more about some of the optional features like IDP inline tap mode that you can do on a high-end SRX, as well as generating your own custom attack objects, or we would call them custom signatures in the Cisco environment. So that should set you up pretty well right there for a basic fundamental IDP or IPS implementation on your Cisco SRX. Okay, I'm at juniper.net. I'm going to products and services and kind of move down. No thank you, no survey today. Let's go to security here. Now, I'm actually a big fan of the standalone appliance as far as IPS sensors go. That's what I use in my rack, and I prefer these in a production environment as opposed to integrating IPS services. There are lots of solutions out there, whether it be Juniper or others, or Cisco has its AIPSSM module for its adaptive security appliance. We also know that the Cisco IOS has an IPS. However, whether it be Cisco or Juniper, I recommend, for a production environment, this is one of those things in the firewall system where I wouldn't want to integrate the services. I like to have the dedicated appliance with all the dedicated hardware and software to the actual intrusion detection and prevention itself. Now, when you compare detection and prevention, detection is really taking copies of the traffic and analyzing the traffic. You're not actually in the line. If it's prevention, you're in the line of traffic, and you can take proactive dropping of traffic that is, adhering to some signature match, for example. And let's just look at the IDP 75 here, because we're talking about the small office, home office, small and mid-sized business. And so you can see a device like this. You can see the maximum throughput, the number of sessions. It also has several different modes. The sniffer mode would be kind of the promiscuous mode, doing packet capturing, and you could use things like Wireshark, for example. There's also a transparent and mixed mode option. There is no support for high availability, though, and that's not uncommon with these types of appliances. So what you would do to have high availability on this IDP 75, for example, is you would need to go ahead and get a couple of them, and then use upstream routers. Let's say your upstream 2320 routers, your Juniper 2300 Series J routers, and have the high availability on the upstream and downstream routers using your dynamic routing protocol. and making sure that you don't have any asymmetric traffic. Or you could also do it with a switching solution between two switches using whatever channel bonding or whatever methods that you're using for aggregating switching channels or trunks. So that's one of the things to keep in mind about these sensors. You have to rely upon the upstream layer 2 or layer 3 devices to provide your high availability solution. That may not be the case. Let's go to the 800 here. So you have an optional bypass. So basically, this is saying you can have what's called a fail open scenario, so that if for some reason these modules fail or the entire IDP fails, you can go ahead and send the traffic through without inspecting it. The 8200 here, same kind of thing. So like I said, on these, what we call them sensors or IDP appliances, we have to rely on upstream and downstream devices for a high availability. Now, what I'm saying it really is this. On the exam, you may need to be aware of these different appliances, and I would recommend for you, if you have the budget for your company or if you're consulting with an organization that's looking at this solution, I highly recommend going with this particular solution. Let's open this up, little PDF here. Here's an example, by the way. If you go up to this site, they have a sample enterprise product portfolio. This is a huge enterprise solution. You can go check it out and kind of see not only where the sensor, the IDP or IPS appliance would lie, but all of the other types of appliances that they have. So this is actually a very well-known product portfolio topology. It wouldn't hurt to go maybe and kind of dig into this and just look at it and kind of get your hands around what Juniper recommends. You can see that as we get into the data center, they have a high-end SRX series there. They're using Metro Ethernet, which of course is very popular. The real retail site, this is where you would see something more like what we're dealing with. Okay, the retail side of the branch office would be using the SRX 100 or 210 or 220. So this is really more in line with what we're looking at here in this Nugget series. So again, remember that just like other vendors, you have standalone sensors or IDP/IPS appliances that are also excellent solutions. Okay, in this nugget of the JNCIS Security Series, looked at the fundamentals of intrusion detection and prevention, IDP as it's been historically called, on the SRX. Consider it IPS going forward in the future, even though it's still called IDP on the exam. We looked at a lot of basic functionality and terminology of IDP that you have to know going into this, and then also the basic steps to go through to check your status, to download attack objects, to get sensor updates, and then the basic configuration of your IDP policy on your SRX. I hope this CBD Nugget has been informative for you. I want to thank you for viewing.